Anyway, so let's look at this problem. So on GitHub, I have some few sample problems. If we want to like run them, it's actually good practice to basically like see a code and put it on Mars and try to like understand how it's working. So here we have basically like a for loop, and we want to convert this one to assembly language or to Mars. So there is basically, so what the code is doing is summing from 0 to some limit. It's iterating through that and adding all those numbers to some variable sum. And sum is starting at 0, limit is 3. So it's gonna be basically go 0, and then 1, 2, and 3 also gonna run because it's equal. And that's it. So how do we do this in Mars? So always we have a data section and we have a text section. So here we don't have anything specifically in memory. We only have like few variables, and we are keeping that on registers. So that's like totally fine, because we don't have like that many elements, and our registers are basically enough to do that. And I'm also using these for basically the system calls. So if you remember, we talked about that. Let's say if you want to print some number, or you want to print some string, so there is a system call. So if we had something like that, we are putting one code in in V0. So that's kind of like a signal what we want to do, and then we had to like maybe put what we want to print or get an input or things like that, and then do system call. So that list of code there is the table here. Some of them we had on the slides, like the most important ones, like print integer we had, print a string we had, but the full table is here. And what I'm doing here is I'm basically initializing some kind of like a constant value here, that instead of putting 1, so I don't need to remember that print integer is actually 1. I'm just putting that print int, so kind of like a constant that it's going to be replaced by 1. So that's all this is about. And then we have the data section, but again, since here we don't have anything on the memory, it's going to be empty. So, and this is our text section. So everything else is going to go into text section. So that's going to be our code, and initializing all these sum, limit, and I. Okay. So how do we do this? And you guys can like you can help me complete this. So where do I start?
Initialize the variables.
Yeah. So what are the variables? So I have sum, and here, just to be consistent, we are saying, okay, sum is in S0, and so on. So how do I do that?
Li.
Yeah. So we have few ways to do. The easiest one is Li. Is basically you give a for example, S0. So you give your registers and you put the value or the constant that you want to put in that. So it's like sum equal to 0. You can literally put the 0 here, and that's that. And then we have limit. So I'm going to take this Li, and then limit goes in S2. And then what was it? 3. So here we have the number 3. And then we have I, which is in S1. So let's do also Li S1. And what is the value of I? We have it here as 0. So I is also 0. So I is equal to 0. So, and I can get rid of this one. So far so good. And one thing I suggest every time, so you're doing some code, run it frequently. So right now, I have only like 3 lines of code. Because I don't want to do a large kind of like a segment or large translation and then find out that, okay, there are like 5 errors. So just run it as soon as you can. So I enable to run, I have to save. And so I think that's how in the MIPS. And let's save it in desktop. So this is like, I don't know, problem 1. save, and you have to assemble and run. So when you assemble, if there is any error, it's gonna tell you down here. So no problem, it ran. And then one more thing that I can see, if I change here, so you can see this is your registers, all your registers on the first tab. There is on hex, or you can see it in decimal. So if I change it decimal, I can see that, for example, S2 is actually 3. So it did initialize. So I have that as 2 in 3. Okay, so now let's do the 4. So how do we do the 4? So what are the steps? So first, every time we are checking this, we're having a check. And then if it's valid, we're gonna run, and that's how we write check. We have a check. If it's valid, we're gonna run this thing. So we have the statement. And then if the statement, like after the statement is executed, we're gonna have this, basically this statement here. So whatever, it could be like plus, plus, minus, minus, you could have multiple statements. So here we have I++. And then what happened after that? After you did this string, 3 steps.
You check for the condition.
So we have to kind of like check again, right? So to go back. So that's how we said we're gonna like basically structure the loops. Like that's the step. We have to break it down. So so here I have a check, and I'm having these. So I'm gonna write it again, but I want to print this also. Get this last part. So after these, I'm just gonna print the stuff. So I have another exit label, which is something that, I mean, I can put anything. So that's end of the program. And here we are just printing that it should be the sum, S0, which is the sum. And doing the system call, and then system exit is just end the program. So nothing fancy here. So I just want to have that to see the sum. And if I save this again, what should I get if I run this on the console? So we are initializing. We don't have our 4 yet. And then we are doing this print, and then we're exiting. So what do you expect to see in the output?
Is it the S0?
It's gonna be S0, which is, I think, 0 at this point. Yeah, so we don't have any logic there. So if I print, I'm just gonna get a 0. Yeah, so far so good. So that's, by the way, another thing, to keep these printed statements. I mean, in general, there's 2 ways. Either you have printed statements, or when you run, you can like step through your program kind of and see each line, and you see like what is changing. So that's another way to debug. But I rather, for a small program like this, I think this is easier. Just put a print statement and check before, like, before you do so much code. So anyway, so let's do this part now. So how do we do the check? What is the first thing before getting into the loop? So we are initializing this. We already did that. So I is equal to 0. The second thing we are doing, we are checking this limit. So I is less or equal than limit. So how do I do that? Because I want to see that, can I even enter the loop? So how do we check this I is less than?
Branch less than, or BLT.
So yeah, but it's less or equal. So
or BLE.
BLE.
Okay.
BLE, and then we set the same order, right? So I is S1, and then limit is gonna be S2, and then so I is less or equal than limit. And then if this is true, what should I do? Where should I go?
Statement. To
the statement. Okay. So let's put a label for like inside the loop, right? Let's put, I think loop, just easier. Okay, loop. Let's do that. So if I have this now, So what's gonna happen? It's gonna check if S0 is less than S1. Sorry, S1 is less than S2, which is I is less than limit or less equal than limit. I'm gonna jump to the loop. So is it okay? Okay, let's continue. I'm gonna put this one to check. This is not okay, but let's continue, and then we're gonna get back to it. So let's say we have this one. It is less, and then we are jumping to loop. So we have our check done. Perfect. Now the statement. What should I do for the statement? This is easy. So it's basically we are adding.
Add initial. Add.
Well, here
Or,
I'm just gonna use add because I'm gonna have to register.
oh,
So the difference between add and add initial immediate is I have to register. That's add, like it will be S1, S2, S3. But add I takes S1, S2, for example, and a number 5, for example. So if
oh,
you
it doesn't take a.
Yeah.
Okay.
So that's the difference only. So if you have two registers, you have to use add. If you and you can see the menu usually here when you put So if you put add, it gives you like that. Actually, well, technically, this is Mars kind of like having these shortcuts. So it actually does accept if you put a number also.
Okay.
Yeah, but it's not. But technically, it's not. So that's the difference between add I. Yeah, but technically, no, it shouldn't. Same thing for example, branches. So if you have PLE, so technically you don't have numbers here, but Mars accept numbers for the second one. It's kind of like it translates for you. But let's just stick to that. Add is 3 registers. Add immediate is you can put a number.
Okay.
So here we are adding sum. So how do I do that? I have sum, which is in S0.
So S0, and then what you're adding, right?
Yeah. So that's gonna be the result, gonna be on the first one. So that's the sum, okay? And then sum plus I. So it's gonna be S0, which is sum, and then S1.
Oh, wait. Yeah.
Yeah. So that's gonna do the add, perfect. And so that's our statement done. And then I plus plus, that's easy. How do I do that? Add I. Where is I? I is S1. So S1, S1, and what do I put here?
1.
1. We are just adding 1 to S1 or to I. So perfect. And then check to go back. So basically so we did the statement. Now we have to check, are we like done with this for, or do I have to go back and start again? So how do I write that check? So what is our condition? We have it here.
Isn't it the same thing as the top one? But
so we have
maybe
that
the
same.
top one's wrong, right? Because maybe something has to jump to exit.
Yeah. So okay, but here this looks good to me, because if I is less than or equal to limit, which what we have here, we're gonna jump to loop. So we're gonna run the loop again. I think that looks good to me, because if this is true, so if I is less than or equal to limit, which is the condition for a loop, so if this is true, jump to loop. Perfect. So we run this, and then if it's true, run the loop. I think that's good. This one,
Okay.
not so much. But before that, let's run this and see what we are getting first of all. So what is our output here? we have, so we're gonna have 0, and we're going to 3, and every time we're adding that to I. So we're gonna have basically 0 plus 1 plus 2 plus 3, right?
Yeah.
Because the equal is there also, so 3 is gonna be added also. So we should get 6. So if I run this, assemble and run, we get 6, perfect. So that's working, but there's a bug here. So first of all, I want to say one thing, that this one, we don't always have to do it. So there is the initial check, and if we are like 100% sure that our initial condition is always valid, I can just skip this one. So if I know like that this I is hard-coded to 0, 100%, and the limit is always gonna be larger than 0, that means like it is always gonna be true. So we really don't need this initial check, because it's gonna run at least one time.
Okay. So this is like in this condition you don't need it because we're hard coding 0, but like maybe in like
yeah. So it depends on the use case, right? So if these numbers are, I don't know, like hard coded, I mean, it still is good practice to have that, because the cost of checking one time is not much. Like if your loop is going to, I don't know, 1 million, what is like one time checking more, you know, versus like, I mean, inside the loop is like more important. So the cost is not much to do an extra check, just to be sure. But sometimes, like on the compiler does actually skip this one, because it knows that, for example, these numbers are hard coded. So it just skipped that.
okay.
Yeah, like the compilers are very smart sometimes. Like for example, in I think like in IntelliJ, for example, it kind of like check your code, and it even gives you, for example, that it says, hey, like this function always is getting a constant value. Consider changing it to final, for example, for the value. So it kind of knows all these things, because it knows that, okay, this where the variable is coming from, and like if the value is getting updated anywhere or not. But let's say these are coming from like the console or something. So we are manually entering 3 numbers. So we don't know about this one. But then what should this be? Because if I put here, let's test it, right? I'm gonna put, well, sum is 0, I is 0. Let's start I from 1 or from 10, and limit, let's go to 11. So what should I get now on this 4? I'm gonna start from, instead of 0 here, I'm gonna start like I'm gonna put it to 10. So I'm gonna start from 10, and this is 11. So what should I get? What is the first time that's gonna be added? Sum
21.
66 maybe, I think.
No. Let's look at it again. So I'm putting I to 10.
Oh,
and
error.
putting, and putting limit to 11.
Oh, it's just 1. Oh, okay, never mind. I thought it was okay. So it just runs once. Or twice?
2 times. So it starts from 10. The first time is 10, I. So what is it gonna be sum? First run.
21.
Yeah. So first time gonna be 10, and then the second one gonna be 11. Right? Is that clear for everyone?
Yeah.
So first time is 10, and then plus is gonna be 11, and then gonna be added. So we're gonna get 21. So if you run this, we should get 21. 21. So far so good. Is it clear for everyone?
Yeah, it makes sense.
Okay, so it starts from 10 and go to 11. But what if I change this 10 to like 9, to this 11 to 9? So this is 9 now. What should I get?
It's not gonna run, right?
It's not gonna run, right?
Yeah. But that's just because of the first check, right?
Yeah. But so I should get 0, right?
Yeah.
But I don't think I'm gonna get 0.
Oh, really?
I'm gonna get 10.
Wow.
So why is that? Can you find the problem? Everyone sees the problem.
I don't see it. I'm guessing it's the condition, the first check, but
okay, so let's look at it.
Oh, is it because since it's failing, it keeps going down?
Yeah.
Or
so
no?
Exactly. Yeah. So branch is less or equal. S1 is less than S2, so I is less than 9. So that's basically here we have 10, right, less or equal than 9. So is this true? No, it is false, right?
Yeah.
So what happens when it's false?
It goes to the next line.
It's going to
the next
continue.
line is, yeah.
So it's going to run the loop, right? Everyone sees the problem?
Yeah. So it should be the opposite, something that jumps to exit.
Exactly. So I want to hear from somebody else also, like if it makes sense. Yeah.
Yeah, it makes sense.
Yeah. Okay. Sounds good. So how to fix this? Basically, we said we flip. So we negate the condition and switch the label. So what is the opposite of less? Is it less? Oh, yeah, less or equal. It's just going to be greater than, right? So this becomes BGT. So we make that greater than, but then we have to switch where it's going to go. So instead of here, it's going to go to exit now. And if I quickly try to draw it. So it was less or equal. So this was our condition. We have two things. The true was the statement. False was, well, next line, which is the statement also. So it was coming, both of them are coming the same place. So now we are sending, this is greater than the true, the false gonna be the statement, and then true, this is gonna be exit, and then it's true. So that's basically what's happening. We just flipped that. Okay, so, and that's it. I think it should be good. So let me just run it. I'm gonna save this, assemble, run, and we get 0. So that means it didn't go inside the loop. And I still want to get the original one. So if I change this one to 11, let's say, run, I'm gonna get 21. So that's it. Kind of a straightforward, just tricky on this part. Any questions?
Wait, question. So if you didn't have, so this is a for loop, right?
Yes.
And this would also be the same thing, like a while loop, right? In
yes.
this case.
Yes.
Okay.
So for loop, yeah, I mean, if you think about it, while you can convert any while loop to a for loop, right? So if you have while, if I want to convert this to a if I want to convert this for loop to a while loop, I'm gonna have while I is less than equal 9, and then what I'm gonna do? I'm gonna do sum plus plus, and then I'm gonna have I plus plus, and that's it, right? And here I have I is equal to 10. You can convert any for loop to a while loop, basically. So I would say, yeah.
Oh, my bad. No, sorry.
No, no, I just want to say that while loop is kind of a general form of a for loop.
Okay. And if you take off the first check, it becomes a do while loop, right? Or
exactly, yeah. So if I have so do that and while, and then you have your condition.
Okay.
Basically. So these are like the general case, but for is very like I think easier to write. Like it's more friendly to read. Like from 1 to, like for example, you say from 0 to 10. You know, it's very straightforward. If you have like one thing happening, and actually here you can have multiple, like and the for loop. I think in at least few languages that I know, but you know, it's just easier, I think, to write that way. Yeah. Yeah, it's just about like thinking about the logic, what is actually happening in this whatever statements you have, and think how like the assembler or how the processor gonna execute like a step by step. That's basically how to put it in assembly.